My name is John, and today I'd like to show you my project SmartEE. SmartEE is an open source, hackable smart plug. It makes it easy to monitor your power usage and control appliances remotely. SmartEE connects to your Wi-Fi network, and with a simple Python script, you can turn loads on and off and continuously monitor RMS voltage, current, wattage, line frequency, power factor, and more. The brains of this project is this custom PCB. The microcontroller is a SAM4S ARM from Atno. The ESP8266 module handles the Wi-Fi, and this microSD card provides persistent storage for data logging, and this battery-backed real-time clock provides precise timestamps. Right now, I'm using a commercial platform to power the SmartEE. This is a disassembled Belkin Wemo Insight. When you buy it, you can crack it open, and there are two boards inside. This is the base board. It has a 5-volt transformer for power, a relay, and a solid-state meter chip for Maxim. There really isn't anything smart on this board, just some basic support hardware. But the plastics and the UL certification make it expensive to design. If I ever get some money, I'll design my own injection molded enclosure and get it UL certified. But all the smarts are on the control board. The stock control board connects with the Wemo mobile app and a few third-party websites. It doesn't have any data logging capability and only exposes a fraction of the metrics that are actually collected by the meter. To turn the plug into a SmartEE, you simply disconnect the stock controller and attach this custom PCB. Now you get all the stock functionality of the Wemo, plus high bandwidth data logging and up to 4 years of onboard storage, and full access to the advanced power metrics collected by the Maxim meter. And, of course, it's all open source, so you aren't at the whims of third-party APIs. Now, you simply put the case back together, and you're ready to go. Let's see how it works. So I've connected the SmartEE plug up here to a hot air gun. When I turn this on, you'll see the paper flutter. And I've also connected it with USB cable back to my computer, so I can control it using a terminal emulator. So I can bring that up here. You see a nice help prompt, so we can see all of the commands available. And I can turn on and off the plug. And I can connect it to the Wi-Fi network. So we need to give it the SSID. And the password. And then I'll raise the debug level here so we can see the traffic between the microcontroller and the ESP8266. And I'll turn the Wi-Fi on. So once you set this up the first time, it automatically connects to your network when you plug into the wall. So now we can talk to it. I've put a couple files in the software repository. Plug.py is a module you can import into your own projects, and that exposes all of the commands to interact with the SmartEE. And to show you how to do that, I've written this demo.py script. So using demo.py, we can set the relay, and we specify the IP address of the plug. And I can turn it back off. I can also read data back from the plug. So the data comes back in a binary format and gets appended to a CSV file locally. And any plotting tool, such as MATLAB or Octave, should be able to plot these files. So we can load back the file, and then the fourth column here is the wattage. So you can see we've turned the plug on. And interestingly, we can look at other metrics like line voltage and see what the effect there is. And you see when we turn the plug on, we actually dip the voltage from about 117 volts RMS down to 115. And we can look at other metrics like line frequency and cumulative energy consumption to make some interesting power quality analysis and look at the health of the utility in your area and other things. So I've designed this whole project to be easy to integrate into your own home or lab to safely and easily automate your appliances. To show you how you might integrate these in a more real-world setting, I'll show you a project I'm working on called Wadsworth, which uses these plugs to expose your data in a web environment so you can easily view how much energy each appliance uses, how much each one costs, and turn them on and off. This is a project that's currently in progress and hopefully will be finishing up later this year. And that's it. Thanks for watching. If you want to try the code out yourself, check out the GitHub repository for all the software, firmware, and hardware design files. If you have any questions, please let me know in the comments. Thanks.